Hi, 95. So we're back to keep going with our exponent rules. So we did the first three, the product rule, the quotient rule, and the zero power rule. So now we're looking at the negative exponent rule. So before we get to that, let's just look at what's happening behind the scenes. Okay, so if I have something like x squared over x to the fifth, I know from my quotient rule that I should be able to subtract top minus bottom for the exponents. So that would be 2 minus 5, which would be negative 3, right? So x to the second over x to the fifth, using our quotient rule, would be x to the negative third. Now also, if I take that same problem, but I write out what's happening like we did before. So x squared is x times x, and then x to the fifth is x multiplied by itself 5 times. And if I think about what I did before and canceling things out, then an x on the top and an x on the bottom can cancel out. So we get a little bit lazy when we just cancel out, but what's really happening here is we're saying x goes into x once, x goes into x once, right? So if I look at what I have on the numerator, 1 times 1 is just going to be 1, and on the bottom I have x to the third. So I started with the same expression. I did two different things with it that are both mathematically correct. And so this isn't a formal proof of these things being equal because we did it with specific numbers instead of just any number. But this is kind of how, if you get into higher math classes where you have to prove things, this is kind of one way of how we prove things. We say, okay, well, x to the second over x to the fifth equals x to the negative third, and it also equals 1 over x to the third. So that means these two things must be equal. So that's one of my examples there actually, is that x to the negative third equals 1 over x to the positive third. And that's what our negative exponent rule tells us, is that if an exponent is negative in the numerator, it will be positive in the denominator, or vice versa. So the second example, I have 1 over x to the negative fourth. If I bring this up, that's x to the positive fourth. Now you might say this doesn't look like a fraction, but remember I can put it over 1. And same thing with this, right? So this is really a numerator. So if our exponent is negative in one part of the fraction, we can move it to the other part and it's positive. And that will make a little bit more sense as we get doing some examples. And then finally, the last thing is the power rule. Oh, actually, I forgot to do the examples there for negative exponent rule. So let's go ahead. So the first one is x to the negative eighth. The second one is 3x to the negative fifth. And the third one is 1 over x to the negative fifth. Okay, so looking at what we had, if we have a negative exponent, think about this in the numerator being over 1, we can pop it down to the bottom to be positive. And I need a placeholder, so I have my 1 there. Let's go down to the last one for a minute. If I have a negative exponent in the denominator, I'm going to put it in the numerator as a positive exponent. Now let's look at this one for a minute here. 3x to the negative fifth. So I will tell you that what people generally want to do at first is to say, well, that's 1 over 3x to the fifth. But that's not quite right. So let's look at why. Okay. Remember I'd said, maybe I hadn't said it yet, but anytime there's a number or a variable that does not have an exponent on it, it's implied that it's 1. I said it in the Zoom class today, so I don't think I said it here yet. So this is 3 to the first power x to the negative fifth. So when I have more than one part to my expression, I want to see, okay, I want to move anything that has a negative exponent, but I don't want to move anything that has a positive exponent. So 3 to the first has a positive exponent. That's not going to move to the other part of the fraction. Just the x to the fifth will. Okay, so you see the difference here. Now, if I'd had 3x in parentheses to the negative fifth, then yes, I would have moved that whole thing down to the bottom. But you just have to be paying attention to what the exponent is actually on. Remember, exponent only goes with whatever it's right next to. So here it's only going with that x. Okay, so now we can move on to the power rule. So let's again start out by kind of seeing what's happening behind the scenes of an exponential expression. So before we get to the one on your notes, let's just start out with one that is a little bit simpler. So let's say I have x to the third squared. Okay. Think about what this means. This means x to the third times itself. And if I have this set up, now I'm back to the product rule, where I have two like bases. I'm multiplying expressions with like bases. I add those exponents. Or from here, you could even break it down further to see what's happening. And x to the third times x to the third, you can see again, that's going to be x to the sixth. Well, where did this 6 come from when I look at my original expression? It came from multiplying those two. So this is where it gets a little bit tricky, because if I had x to the third times x squared, that's going to be x to the fifth. But if I have x to the third squared, that's going to be x to the sixth. Here I add my exponents, here I multiply my exponents. And this is why I said right from the beginning that yes, you need to know the rules, but you also need to know how to figure out the rule so that if you forget which one you're doing, you can recreate it. Okay? So this is really the power rule, saying that if I have an expression and I raise it to a power, I'm going to multiply those exponents. Now to expand on that, let's look at the example in your notes. So it's just a little bit larger example. So I have x to the third, y to the fifth, z to the fourth, and this whole thing is raised to the second power. So just like here, these were multiplied, here this is getting multiplied by every single exponent inside. So basically your power rule says the outside exponent gets multiplied by every single inside exponent. So this is where you can see that I have the answer in the notes. This is going to be x to the sixth, y to the 10th, z to the 8th. And if you wanted to see where this came from, I mean, you could still think this squared means this times this, so you'd have another x to the third, y to the fifth times y to the fifth, z to the fourth times z to the fourth. Okay, let's look at the you try one. So again, I would recommend that you pause the video and try it, and then come back after you have. And even if you get it wrong, that's okay. That's how you know you're learning. Okay, so we have x to the negative second, y to the seventh, z, that whole quantity to the third power. So now go back to what I said a minute ago. Anytime you have a variable or a number without an exponent written, it's implied that it's 1. So we're going to put a 1 right here, because you want to remember that. Okay, so now the outside exponent gets multiplied by all of the inside exponents. So we end up with x to the negative sixth, y to the 21st, z to the third. And then if you look below that, it says now write your answer using only positive exponents. So again, these two have positive exponents. This one doesn't, but we know we can take it to the denominator to make it positive. So what I generally do, and you'll see when we get some more complicated ones in a minute also, what I generally do is I go to each part of the expression and I just think, okay, is this part going to stay or is it going to move? So in this case, x to the negative sixth, that has to move to the bottom to become positive. Y to the 21st is going to stay because it's already a positive exponent. Z to the third is going to stay because it is already a positive exponent. Okay, so those are our 5 rules. When we multiply expressions with like bases, we add the exponents. When we divide expressions with like bases, we subtract the exponents. Anything to the 0 power is 1. The negative exponent rule says if there's a negative exponent, we can move it to the other part of the fraction. And finally, the product rule, or the power rule says that the outside exponent gets multiplied by every single inside exponent. So we're going to start putting those together. And again, I would really suggest that you stop the video, go to page 3 in your notes, and work through those problems, maybe a couple at a time, and then turn the video on and check your work, okay? Just watching me do it is not going to be the practice you need. You need to practice it on your own. Check your work, see if you're making a mistake, that's fine. And often it might be the same mistake that you're making over and over, which is actually good. You might remember me saying that earlier in the semester when we were together. I'd rather have you make the same little mistake over and over, then once you fix that, you've got it all fixed. Okay? All right, so number 1 on page 3. So at the top it says, let's practice these rules, simplify each expression, always write your answers using only positive exponents. Okay, so number 1 says 6ab times 3a cubed b to the negative 4th. Okay, now to start out, I see that I'm multiplying these two expressions first of all. All right, so I look at these numbers right here, and these are not the same base. Okay, sometimes you'll see like 3 squared times 3 to the 5th. These are not the same base. So if I just have numbers that are not the same base, they're being multiplied here, I can just multiply them as I normally would. So I'm going to have 18. Now looking at the other numbers, this is where we want to think about the fact that anything without an exponent has an implied 1 there. So those first two, the a and the b. So now we have a to the first and a to the third. Two expressions, same base, I'm multiplying them, I'm going to add my exponents. Same with the b's. Okay, so at that first pass through, I have 18, a to the 4th, b to the negative 3rd, because 1 plus negative 4 is negative 3. Now, this would be fine, except it said that we want to have only positive exponents in our answer. So I go through here, because I see that I have a negative. So 18 is to the first power. That's going to stay where it is. A to the 4th is to the first power. Or sorry, a to the 4th is to a positive power. That's going to stay where it is. B to the negative 3rd has to move. It's going to go to the bottom, and it will be b to the positive 3rd. Okay, let's look at number 2. Number 2 says 2xy times negative 4xy to the 4th. Okay, so we're going to just multiply the numbers. So negative 8, this has a 1, this has a 1, this has a 1. So x times x is going to be x squared. Y times y to the 4th is y to the 5th. Okay. Notice there are no negative exponents here. Just because there's a negative in the answer, it's kind of in my glare here, but there's a negative right there from negative 4 times 2, does not mean there's a negative exponent. So this does not change. This does not move. Okay, this is not 8 to the negative power. It's just negative 8. So this is going to be our answer. Okay. Number 3. X squared times 4x to the 3rd times y to the negative 4th times 4y squared. So I'm going to use the product rule for all this, right? It's just all being multiplied. So 4 times 4 will give me 16. X squared times x to the 3rd, I'm going to add those exponents. Y, negative 4 plus 2 is negative 2. And by now, hopefully you're in the rhythm of this. If I see a negative, I need to move it. So 16 is to the first power, it stays. X to the 5th stays. Y to the negative 2nd goes down to the denominator to be positive. Okay, I'm almost up to my 15-minute limit here of what I can upload, so I'm going to stop this and come back to do number 4.